Good evening, everyone. This is Veer Maheshwar Charitable Trust Latur MS India organizing daily international webinar series. This series is running from last 5 years and speakers are invited from India and abroad. Every day the speakers are delivering their topic on various subjects. Today on 22nd May, we are invited Miss Chaithanya C ma'am, who is Assistant Professor, Department of Artificial Intelligence and Data Science, Adi Shankara Institute of Engineering and Technology, Kalady. The topic is Deep Learning Demystified, Powering AI Everywhere. I welcome you, ma'am, from my organization and from all the participants.
Thank you, sir.
Adi Shankara Institute of Technology has supported very much to us because so many speakers have accepted our invitation and delivering their topics. So I'm very happy with the institute and welcome you, ma'am, and welcome all the participants. I request you, you can start your speech now. Thank you.
Okay, thank you, sir.
You can start your speech now, ma'am.
Okay, okay. Is the slide is visible?
Slides are visible, please.
Okay, okay. So the topic for today's webinar is Deep Learning Demystified, Powering AI Everywhere. As you all know, we are using AI in our day-to-day life from the basic face looking towards the chat GPT, right? So AI made us all these things possible. When you think about AI, the goal of AI is to create the smart missions. And when you think about machine learning, it basically focus on how the data is learned. Now, what makes the AI or what gives the power to this AI? Like we are basically using the AI to unlock our devices that like fingerprint analysis and towards the chat GPT, what we do in our what we use frequently in our day-to-day life. What gives the AI this much power to be used? That is deep learning. Deep learning is basically an engine behind the current AI revolution. That is the relevant of this topic. The deep learning basically gives the power to the AI. What is basically a deep learning? Deep learning is a subset. We can define the deep learning as a subset of machine learning where we are using the layered architecture inside the neural network. Neural network is the mimicking of biological neurons. We have biological neurons in our human brain that gives the capability to the human brain to think and analyze the data. That is the specialty of human brain, right? You can think, you can gain knowledge from your experience, and based on the knowledge, you can make the decision based on the knowledge that you already know. That gives the power to the deep learning architecture. Deep learning has the feature that it can learn the features by its own instead of compared to all the traditional machine learning methods where we have to explicitly or manually give the features and tell the algorithms how to make the decisions. In deep learning, the deep learning models have the ability to learn by itself. We have a layered architecture in deep learning where the layers basically filters your data. You are giving the raw data like normal filters where you give the raw data, and after each filtering process, your data get refined and you will get a more accurate data as your output. Similarly, in deep learning, you have a hierarchy there. A lot of filtering systems are there, a lot of layers are there where your data is getting filtered and your data will be refined as an output. That, that is the importance of the word deep in the deep learning. You have a multiple hidden layers in the neural network. Artificial neural network, you have a multiple hidden layers in the artificial neural networks. In traditional machine learning, humans must manually label the features. Like if you are trying to classify your data, if you are giving a set of images and you are expecting your model to classify it as a cat or a dog, and you have to tell the model that these all features are there. Cat has pointed ears, or cat has this much height, cat has these features. That was in the traditional machine learning models. But in case of deep learning, the depth, that means you have a multiple layers, multiple hidden layers in your model, and that each layer studies the features automatically. You need not to tell the features explicitly. The data hierarchy is an important thing in the machine learning. It works like a filter. The first layer will detect the simple edges, and the next layer detect the shape, and the next identifies the texture. Likewise, if you had more and more layers, each layer identifies the features, and the final layer that identifies the complex object. Like if you're trying to identify it as a cat or a dog or a human face, at the final layer your model will identify the complex object. That is a feature of deep learning. So instead of giving everything manually, you are making a model that is capable of learning by its own. That capability of deep learning gives the power to the today AI revolution, that given the power to AI revolution to learn by itself and make a more accurate prediction about the input. So, what makes AI more powerful? First thing, as we told, that it can automatically learn the useful features directly from the raw data without manual intervention. It can learn by its own. This significantly reduces the need of handcrafted rule. You need not to specify the rules, or need not to specify the features. You need not to tell the model that these all things to be considered, and so on. And the key strength is the scalability. The second feature is the scalability. That is, you can use a larger data set to train your model. The more the data you train the model, you will get a more accurate model. That is, the performance of your model becomes greatly high. This is why the massive data production companies like Google, Meta, they heavily invest in the deep learning researches. And next thing is the accuracy. As you are training the model with a larger data set, you get a very accurate result from the deep learning model rather than the traditional methods. So accuracy in the area like computer vision, speech recognition, natural language processing, all this enable the capability of deep learning. It can solve complex tasks such as autonomous driving, language transition, and medical diagnosis. So these all features makes the deep learning more relevant in today's life. Now, how this is achieved in the deep learning. Today, I'm going to discuss about what is basically deep learning, what is the capability of deep learning models, and how this is achieved in a deep learning model. For that, we will discuss the architecture of deep learning in a very simple version, and how it basically works and how it generates the output like a human thinking. So, moving into the architecture of deep learning model, basically the depth defines the network. How depth is your network means how it makes the more accurate network. So the number of hidden layers, you can see that a deep learning model basically has 3 layers. First one is the input layer, second layer is the hidden layer, and the last one is output layer. Basically, input layer receives the raw data. If you are trying to classify an image as a cat or a dog, then the raw image is given to the input layer. It could be an image in a pixel format. It could be a text based on your application. Your input will be given into the input layer. It receives your input into your architecture. Then the second layer comes. It is a hidden layer where the actual computation is performed in the hidden layer, and each feature is extracted in the hidden layer. So if you have more depth features to be considered for predicting the output in your model, you can increase the number of hidden layers. And the more the hidden layer in the network, the deeper the model becomes. And finally, you will have an output layer. The output layer, the function of output layer is it basically generates the final prediction. That is the final output of your model. Whatever you are trying to develop using a deep learning model, the output will be given by the output layer. So basically a deep learning architecture, it will consist of an input layer and an output layer and a number of hidden layers. The number of hidden layers depends upon how depth you are trying to analyze or how many features you are trying to analyze will decide the number of hidden layers in your network. So the depth is important in the case of how deep your model is. That is important in the case of a deep learning model. Now, as we told that deep learning models are basically used for mimicking the human thinking capability. That how the human thinks, that capability has to be adapted into a deep learning model to make an AI model to mimic like a human being. We are expecting the AI model to think like a human being, right? So the capability of human brain, that is the capability of human brain has to be adapted into a deep learning model to make it think like a human being. Here in the slide, you can see the comparison of human brain and a deep learning model. It is very related to the working of a human brain. In human brain, in human brain or in human thinking capability, how we make the decision is we perceive the input through our sensory inputs, right? Like ears, nose, and so on. We take the raw input from our surrounding environment, then the neurons in our human brain process those informations. These informations are processed. There's raw informations that we receive through our sensory inputs, and they are converted into features that could be analyzed by our brain. The neurons in our brain actually process the information, and then that information is learned inside our model. That informations are converted into knowledge in our brain, and this knowledge are given for the decision making. And decision making means it produces a certain output based on our input, right? What if we want to move any part of our body based on the input we have received, that instructions will be given as the output from our human brain to the corresponding part. This is how basically a human uh, brain works, right? When we relate this to a deep learning model, our sensory inputs are related to the input layers. As we told that our deep learning model basically has uh, three layers. So input layer in the deep learning model is like our human brain receive the input through our eyes or ears, and that raw data is given to the input layer as image pixels. If you are trying to analyze an image, or if you are trying to analyze an audio signal, then your input signal will be an audio signal. Or if you are trying to implement any NLP task, then your input will be in a text format, right? Anyway, the raw data will be given into your input layer, and then this inputs will be passed to the hidden layers, where your architecture, new artificial neural network architecture will consist of multiple layers of artificial neurons, and neurons will extract the features from lower level to the higher level patterns. And each layer, your input will be processed, each features will be analyzed, and then at the output, you will get an output. That output won't be considered in the initial state. Your model has to be learned. As a human being, as we learn from our experience, we are expecting the deep learning model also to learn from its output generated. There comes the error calculation. We, we calculate the error occurred in our architecture, and this error is back propagated to your network. That is the training phase. You identify the output, you pass the input to the hidden layer, then from the hidden layer to the output layer. At the output layer, you analyze your output obtained. If there is any error occurred, you train the model, you back propagate the errors back to the layers, to the previous in the backward direction to the previous layer, from there to the next previous layer, and towards the input layer. You are back propagating the signal when the error is occurred, and you are updating the network architecture. Accordingly, the learning process happens in the model. Then uh, at the learning process, the network automatically learns the abstract concept and capture the true meaning of data. When you iterate through the network, after each epoch, your network will learn from each iteration, and your network will get updated. And at the end, the output layer makes a prediction. After a number of iteration, you can see that your error rate will be reduced, and the output will be produced. And then you can stop training your model. Then your model is capable of producing the output, and the model is capable of making prediction. Whenever you, after training phase, whenever you give a new input to your model, then model will be capable of making prediction, or classify your data. When you are giving an image of cat and dog, your model will be able to classify the data as a image as a cat or as a dog, or make a final decision. You can use a deep learning model to make a decision, and so on. So basically, when you compare these two architectures, like the architecture of human brain and the architecture of deep learning model, you can see a more similarity in the implementations. So here we are trying to develop uh, we are trying to mimic the working of biological neurons into an artificial neural networks, and this artificial neural networks give us the capability for the deep learning models to mimic the capability of human brain. That is, we are gaining the knowledge from our experience. Once you gain the knowledge, whenever you encounter a new situation, you are able to recover that particular knowledge and make the decision based on our previous knowledge, right? So that gives the capability. Now into the deeper into the architecture, as we told that the neurons in the deep learning architecture, the artificial neuron architecture, the neurons in the architecture that gives the capability of human thinking. The neurons are basically inspired by the biological neurons in the human brain. They consist of, the architecture basically consists of, as we told that we have three layers, that is input layer, hidden layer, and output layer. In each layer, we have a certain nodes that is known as neurons, that resembles a neuron in our human brain, and we have individual neurons, or that is known as nodes or neurons in each layer, and nodes in one layer are interconnected to the nodes in the other layer. And each neuron receives the input. Each neurons in the input layer that basically receives the input, they apply weight and bias. We are applying the weight and bias into the neuron, process the information, and pass the result forward until we reach the output layer. And in each neurons, in the hidden layer and output layer, we are using a function known as activation function, basically that are introduced to introduce basically they are used to introduce non-linearity in your data. There are different activation functions are used in your in deep learning models. Based on the application you are trying to implement, you can use different activation functions in each neuron. Basically, it allows the network to solve the complex problems instead of only simply finding the linear relationship in your data. If you are not implementing activation function in neuron, whatever the input you are receiving will be transmitted to the next layer in your deep learning model. So instead of passing the data from one layer to another layer. Our aim is to process the data, extract the information or extract the features that are needed for identifying the output. So that is why we are introducing activation functions in each node. Classical example of uh, application that are implemented using a deep learning model is handwriting recognition, where we are using a MNIST data set, which learns the data set basically used to train the model and used to classify the data from 0 to 9. It identifies the data from 0 to 9 by recognizing the data given to the model. Then inside the artificial neural network, the artificial, as you can see, that artificial neural network basically consists of these components. That is, the first primary unit or primary thing in your artificial neural network is the neuron. It is a basic unit in your artificial neural network which does the processing of your data. Then each neuron in one layer will be connected to the other neuron in the next layer through a weighted interconnection. The weight is associated to give the activation functions are computationally efficient and works well with your deep networks. Then we have TANH function, where the output values between -1 and +1. And we have softmax function, which is commonly used for multi-class classification problem. If you are not classifying if you are not using your model to classify the data into two classes, if you are trying to classify that into two classes, means it is basically a binary classification. If you are using a multi-classification, if you are trying to classify your data into 3, 4 or more classes, then you can use a softmax function for performing multiple classification problems. And these components, they work together to help the network to learn meaningful pattern from the data. If the network is capable of learning meaningful pattern from the data, that makes the network to think by itself. If you are giving new data, your network will learn from the data and make the decision accordingly. So you need not to sit manually and train your model. Once you develop the model, your model will able to learn from the new data that receives and make the decision accordingly. So training a deep learning model, now we discuss the architecture, right? So we discuss what is basically a deep learning model is and how the architecture of deep learning model comes. Now we are moving into how to train a deep learning model. As we told that the training a deep learning network is similar to teaching a student. That is, how a student learns from the feedback and corrections. So first, during the forward pass, we have different forward pass and backward pass in the deep learning model. First, during the forward pass, that means your data is moving from the input layer to the output. And now then the loss function is measured. At the output layer, you are trying to evaluate your model. The loss function, the error occurred in you are trying to measure the error occurred in your model. The loss function measures how far the prediction is from the actual answer. Then if there is any correction, next comes the backpropagation. You are backpropagating the error, where the error is backpropagated through the network, adjusting the weight to reduce the mistake in your model. This process repeats many times until the model achieves acceptable accuracy. It is also important to remember that the performance of your model, it basically depends upon the quality of data that you are used to train your model. What data set you are used to train your model, the quality of data in your data set, it is very important when you are training a model. So we have to choose a data set to train your model very wisely. It should be very updated data set with more accurate data, more accurate features. If your data set is poor in quality or it is biased, it will lead to an inaccurate result in your model. So this shows a brief summary of deep learning workflow. From first thing, you have to collect your data input, then you process your data. After processing your data, it makes a prediction on your data. Then the error calculation is done. That calculated error is back propagated to your network, like giving a feedback to the student. Okay. After, if you are trying to evaluate your student, we train them, right? We teach them, we teach the student and we evaluate them through some sort of evaluation criteria. It could be a test paper or it could be a YY. You are evaluating the student and you are giving the feedback to the student to make the corrections what he made. That makes him to learn the new things and make him to be a, more accurate in that process, right? In the similar way, after the training phase or after the forward pass, the error is calculated in the deep learning model, and that error is back propagated as a feedback mechanism into your model, and that based on that feedback your model will learn and or make the updation in your weight and bias, and the architecture of the network get updated, and after a certain number of iteration, the error might reach a saturation point, or it might converge to a certain point, and then you can stop training your model and can be used for the testing phase and validation phase. And the cycle of prediction, error calculation, and the correction is what enables the machine to basically learn. So, types of deep learning networks. These are the basic deep learning networks that are currently used. We have a lot of deep learning models currently available, and I'm just discussing some basic models here. For different neural networks are designed for different tasks. You can use different for neural networks for different tasks. They give accuracy according to your data. The accuracy varies according to your data you are using, based on the application you are using, and they are intended for different type of applications as well. So basic neural networks, that is artificial neural network, they are basic architecture that is used for deep learning models, and they are used for general prediction and classification tasks. Second one is CNN, that is convolution neural networks. They are specialized for image related tasks. When you are dealing with images, you are trying to classify the data, or you are trying to your data and make predictions. Then next one is RNN, or recurrent neural networks. They are basically used for sequential data, like speech and text data. If you are trying to deal with a speech recognition system, or you are trying to implement any text analysis system like sentiment analysis and so on, you can use RNN for analyzing your data. Then the fourth one is LSTM, long short-term memories, or advanced version of RNN, that can remember the information for a longer period. If you are expecting your model, uh, if you are expecting your model to remember the information for a longer time, longer period, make them useful for, basically you can implement that using an LSTM. Like you can make them useful for forecasting or time series analysis examples. Then the last one is GAN, that is generative adversarial networks, can generate realistic image. It can generate the images. It can generate the videos. What we are currently using, we are currently generating images using ChatGPT, Gemini, and so on. Basic architecture is GAN. GAN is the basic architecture. Here we are using some advanced architecture for current implementations. And it generates the realistic images, videos, music, and are widely used in AI generated contents. These are the basic architectures that is currently used in the deep learning networks. So into the real world applications, as we told that deep learning gives the power for AI to think like a human. So the applications of deep learning models are vast variety. Image recognition, basic image recognition, where you detect the objects, detect the images, everything comes image recognition. It helps to identify the face, objects, and senses. It's an application of deep learning model. Then the second one is speech recognition. powers the voice assistance and transcription systems. And in healthcare, deep learning assistance with disease detection, medical image analysis, and diagnosis support. Then autonomous vehicles relies on deep learning for navigation and obstacle detection. Then recommendation systems, personalized user experiences on platforms like Netflix, Amazon, and Spotify. You can see that when you buy a product in Amazon, it automatically suggests or recommends similar products to you. Or in Netflix or Amazon Prime, if you watch a movie, you will get a recommendation that is similar to the movie that you have already watched, right? That recommendation systems basically works using a deep learning model. And deep learning is also used in cybersecurity, for fraud detection, transaction systems, and intelligent chatbots. So the applications of deep learning varies indeed. In nowadays, we have a vast variety of applications of deep learning. So advantage of deep learning, as we discussed earlier, it has a very high accuracy in deep learning model compared to the traditional models, because we are training the model. Since our architecture is so deep, since our architecture has a large number of layers in our architecture, so we can train the model with a larger data set, so it makes the higher accuracy in your data set. So one big advantage of deep learning model is its accuracy in the complex task. Second thing is it can automatically learn the features directly from the data, reducing the need for a manual engineering. You need not to instruct each and everything to your model. It can learn by itself. And second one is its performance improves more training data becomes available. More and more you give the training data. How large your training data is makes your mm, makes your deep learning model more deep. Deep learning is also excellent at handling higher dimensional and complex data sets. Then, additionally, it enables intelligent automation across industries such as healthcare, finance, manufacturing, and transportation. It enables automation, that means minimum human intervention is needed in an AI system. So, as of now, we discuss the architecture, the advantages of deep learning, the applications of deep learning. Even though if it has a deeper strength, despite of its strength, deep learning also has some challenges. As we told, when the data set is large, your deep learning model is more accurate. So it has another way. So in order to train a deep learning model, you need a large amount of data, right? It requires a massive amount of labeled data and powerful. When your data set is so large, that means you need a more powerful computing resources like GPUs. So it is very data hungry. That means it needs a massive amount of labeled data, and it needs a powerful computational resources to process the data. Then training large language models can take hours. Since your data set is so high, that means your model will take a longer period to get trained. That is hours, days, or even weeks to get trained. Then interpretability. Deep learning models are often considered as a black box, because it can be difficult to understand exactly how the decisions are made. That means how the network is actually learning what is happening inside the hidden layer. As the name indicates, the information is hidden from the end user. You can interact with the input layer, you can interact with the output layer, but the hidden layer works by its own. So how this interpretation is done is basically it is difficult to understand in the case of deep learning model. Then implementation and maintenance cost is very high in the case of deep learning model. Then deep learning models. Then into the future directions, as we told that today we are using the deep learning models in our day-to-day activity, but it has a lot of future scope also. The future of deep learning model is focused on the efficiency, then sustainability, collaboration with the human. So first one is a TinyML. TinyML, we are currently implementing TinyML in a small scale in IoT devices. TinyML, it basically aims to run AI directly on small edge devices like wearable devices, sensors in our IoT applications, IoT devices, we are trying to implement TinyML. It is the smallest version of ML. It is a lighter version of ML where we are using a lighter architecture where we can analyze the data in the edge devices as well. Then the future scopes comes with multimodal data, multimodal models. You can combine, that is in deep learning architecture, you can combine both text, image, audio, and video understanding into unified systems. Then researchers are also working on sustainability. That is how to reduce the energy consumption. As we told that deep learning model, it reads a larger computation. The energy consumption also very high in case of a deep learning models. If you are trying to implement a larger deep learning architectures, the energy consumption will be very high. So the research is happening in a sustainable AI field, so that how can we reduce the energy consumption and the environmental impact while using an AI system. And finally, human AI collaboration. Emphasis: AI as a tool that augments human creativity and productivity rather than replacing human. So we can use these models for making our day-to-day activities more easier rather than replacing the human. You can use it as your assistant to make your day-to-day activities more easier. Then, so we discussed the what is basically a deep learning model, what is basically its architecture, its applications, future scope, how it makes decisions, and so on. So into the conclusion, to conclude, deep learning is basically a powerful technology based on a layered neural architecture. That layered neural architecture basically enables it to automatically learn the representations from the data. It learns the from features from the data. It powers many modern AI systems we use daily, from healthcare and self-driving cars to recommendation systems and virtual assistants. However, challenges such as bias, your model could be biased based on the data you are giving, based on what data set you are basically used to train your model. Your data model will be biased. There's a chance of your model being biased. Interpretability and energy consumption requires a responsible development and deployment in the field. That is what the future of deep learning we need to be study. If you want to learn, I encourage you to learn through many platforms are available, and I encourage you to explore the platforms like Google Colab to implement the deep learning model. I just gave an overview regarding the deep learning architectures. You can try to implement the deep learning model in Google Colab, Keras, and Fast AI for hands-on practices. So thank you all. Thank you all for being part of this webinar. I'm open for the question. If you have any doubts, you can ask. Thank you, sir. Okay.
Good evening, Dr. BETKAR sir, and good evening, ma'am. Wonderful presentation. More of the IT sector, and on the other side, you were talking about the biology. So biotechnological, that discussions I could recognize. I belong to this medical field, so we know how the neurons and how the chain of neurons and how the synapse, how they work in an integrity. If there is no integrity, you'll find it will, the whole mechanism will collapse.
Yes, yes.
I think similar thing, we what we are discussing in a depth learning also. So data always form the denominator, and that denominator is very important for any kind of study. So what we are learning today is also, where we require this basic data. So my question is, when we are getting data, sometimes we get, some spurious data, or sometimes, it is not a realistic data what we are getting.
Yes,
And
yes.
then build our assumptions on those things. So I think the whole things will get collapsed. So can we neutralize all these errors, data filtering, what is called as, can we do it with the technology? Thank you.
Yes, yes. As you told that the authenticity of data that you use to train your model is very important, because based on that data your model is making, or your model is trying to learn. So when you are using a data set to train your model, you have to be you can use a certain tools to analyze your data and make accurate choose when you're choosing your data set, you have to be.
Yes, thank you, ma'am.
Okay.
Thank you very much. Really appreciable presentation. Thank you.
Thank you, sir.
Thank you, Dr. Sanand Shukla, sir, for discussing with our speaker on today's topic. I request other participants they can discuss with our speaker on today's topic. I will share the feedback link in the chat box. All are requested to fill it so that you can receive your certificates. Feedback link is available in the chat box now. Today we welcome our respected director Veer Ganacharya sir, who is present here. And within this special month, he is praying in Mauna Sadhana. He will not speak in the whole month of this Adhik Mas in Marathi. He will be in praying without speaking anything. He will continuously working, worshipping throughout the month. I welcome you, sir. We require your blessing. Thank you. Thank you. Other participants are requested to fill the feedback link. Feedback link is available in the chat box. Thank you, ma'am, for accepting our invitation and joining here as a speaker. It is a great experience to learn from all the speakers, because basically they all are delivering the topics on AI. So your institute is Technical Institute, and this useful topic we are listening from all speakers, so that we also get the knowledge from all the speakers from Adi Shankara Institute. And this is the great thing is that everyone have delivered very studiously and prepared the slides very perfectly. They have did hard work for us. I am very much thankful to you and all the speakers. In future also you will be here as a speaker on a topic as per your convenience of time. Thank you, ma'am. Thank you.
Yeah. Thank you, sir, for inviting us and giving us the opportunity to be part of such a big initiative. Thank you, sir.
Thank you, ma'am.